All right, we are starting Unit 9. Unit 9 is your right triangles and trigonometry unit. So we're going to introduce some trigonometry as we go through this unit. Okay, some new skills for everyone. But we're going to start with something we know and are comfortable with, which is the Pythagorean theorem. Okay, we've been working with the Pythagorean theorem before. We're kind of comfortable with this, so we're going to get more practice with it today. So we're going to do the Pythagorean theorem today, and we're going to work on the converse tomorrow and classifying triangles tomorrow. So a right triangle, remember Pythagorean theorem only works for right triangles, okay? The sum of the squares of the legs is equal to the square of the hypotenuse. All right, so we know this equation is a square plus b square equals c square. All right, and if we forgot, a right triangle, come, halfway decent. All right, you have two legs that make up the right angle. Okay, they are legs. Your legs are always A and B. Okay, so A and B are always the legs. Okay, always the legs. They always make the right angle. If it's not making the right angle, it's not a leg. Okay, across from the right angle, all right, across from the right angle is the longest side, and that longest side is called the hypotenuse, and that is always C. Okay, C is always the hypotenuse. Okay, and it is always the longest side. So it is the highest number. So if you are just given lengths of sides, if you put them in order smallest to largest, the two smallest are your legs, and the largest one is always your hypotenuse. Okay? So let's do a couple things that we learned before. We're going to find missing measures using the Pythagorean theorem. I want to cover one more thing, sorry. We're going to cover something called the common Pythagorean triples. All right, so if you have a 3, 4, 5, 5, 12, 13, 8, 15, 17, 7, 24, 25, these are called Pythagorean triples. That just means all three sides are whole numbers, all right? So if you take these traditional top four and then multiply each side by 2, you get a next set of Pythagorean triples. Multiply each side by 3. All right, you get the next set. Multiply each one by 4, and so on and so forth. So if it is a multiple of these top 4, it's a Pythagorean triple. Now, if you start recognizing these and memorizing these, your math will get simpler because there'll be no math involved. If you have 2 of these sides, you'll know automatically that is the third. Okay? So, with that in mind, let's do these. All right, so we have got, all right, a right triangle. We know it's a right triangle because it has our little square in the corner. And our legs are A and B. And x is the hypotenuse. And we're going to solve for x. So a squared plus b squared equals c squared. Okay? So 7 squared is 49. 17 squared is 289. And that equals x squared. Well, 49 plus 289 is 338. And that equals x squared. But do we want x squared? No, we want x. So the opposite of squaring something is taking the square root of. what you end up with is x equals the square root of 338. Well, we can simplify that. Okay, and we can simplify that in one of two ways. Put this in your calculator, and you get x is approximately 18.38. Now, as we get further and further in the trigonometry, we're going to need to have these and learn how to work with numbers that still have radicals in them, or in their simplified radical form. So what we have to do with this is what is called a prime factorization tree. Okay, I'm going to introduce it here. We'll reintroduce it because it should have been something you covered in your algebra class. So I'm going to reintroduce it. I'm going to review it for all of those who either didn't catch it in their algebra class or just needs a little review. So you take a number that's under the radical. And we call it a tree because then we have our branches. And what we're looking for with our prime factorization tree is for the end of your branch to be a prime number, or a number that is only divisible by 1 and itself. Okay? So I take out the lowest obvious prime number, and I keep going on my branches until I end up with branches that only have prime numbers listed. Okay, so here's how this works. So the lowest obvious prime number is 2. Your prime numbers are 2, 3, 5, 7, 11, 13, things of that nature that are only divisible by 1 in itself. Now, we wouldn't want to use 1 because, well, it will not have broken up 338 any smaller. Okay, so 338 divided by 2 is 169. Now, 169 is a perfect square. That means that you have the same number multiplied by itself. So we are doing the square root of, so we're looking for pairs of numbers. Because here's what you have, okay? You have the square root of 2 times the square root of 13 squared. All right, now we have said that squaring and square rooting cancel each other out, so we can bring this 13 out from under the radical. And what is left? The square root of 2. So x equals 13, the square root of 2. Okay? So there are different math scenarios where sometimes we will be using the decimal and sometimes we will be using the simplified radical version of our answer. Okay? So we'll be reviewing prime factorization trees as we go along through this unit. All right, using the Pythagorean triple. So if you can recognize that this is on our list, okay, or is, one of the multiples of one of our core Pythagorean theorem, Pythagorean triples, you don't have to do any math to show your work on the assignment. I'm going to, in your notes, this is a Pythagorean triple, by the way. It's literally labeled that. I am going to show you, though, this problem mapped out to show you, 1, why the Pythagorean triple works, and 2, this is a missing leg. And so the math is slightly different when you're missing a leg versus a hypotenuse, and I want to make sure you have that concept. So we've got Pythagorean theorem, so a squared plus b squared equals c squared, so 14 squared plus x squared equals 50 squared. 14 squared is 196 plus x squared equals 2500. All right, now x squared isn't isolated. It is on the same side with 196, so we're going to subtract 196 from both sides. You end up with x squared equals 2,304. We don't want x squared, we want x, so we're going to take the square root of both sides. And when you do that, you end up with x equals 48. And that is on our list of 14, 48, 50. Okay, Pythagorean triple. But I wanted to you to see the difference, the additional step that has to be taken when you're trying to find a missing leg versus just finding the missing hypotenuse. Okay, there's this additional step here to isolate your x squared that I want to make sure that you're aware of. Okay, all right, let's flip this over. Let's talk about a real-world example. All right, there are many real-world examples of using Pythagorean theorem. Okay, one of them, zip lining. Okay, zip lining is fun. I've done it. You got to push me off that platform. But there's a platform above the ground, and you go diagonal down the zip line to the ground. But it's fun. So a summer camp is building a new ziplining course. The designer of the course wants the last zip line to start at a platform 450 meters above the ground. So we're going to assume this platform is vertical straight up. Okay, vertical straight up, 450. Okay. And the end is 775 meters away from the base of the platform. Well, the base of the platform is just the bottom of the platform, 775. And what are we looking for? How long must the zip line be? All right, how long must the zip line be? All right, well, we have got our A, B, and C. I always try to draw a picture of any word problem I have to help me visualize it and make sure I keep all of my math straight. So it is a right triangle because hopefully the platform is vertical straight up and down, and hopefully your ground is straight across. So it's A squared plus B squared equals C squared. And we're going to fill in what we've got. We've got 450 squared plus 775 squared equals x squared. Well, 450 squared is 202,500 plus 775 squared is 600,625. That equals x squared. Add those together. That's an kind of obnoxious number. It's 803,125 equals x squared. But remember, we don't want x squared, we want x. Okay. So take the square root, and when you aren't told anything, usually it'll tell you what to round to. So I'm going to tell you to round to the nearest tenth. Okay. Round to the nearest tenth in your calculator, and that gives you x is approximately 896.2 meters long. Okay, again, I'm going to do the prime factorization tree for this, just to have in your notes so you can practice it. So 803,125. The smallest obvious prime number is 5 to come out of that. And that brings it down to 160,625. Again, smallest prime number that's obvious is 5. And that brings you down to 32,125. Again, there's an obvious 5 to come out. And that brings you down to 6,425. Another obvious 5 to come out. This takes you down to 1,285. Obvious 5 to come out. And then lastly, 257. I couldn't find any really good numbers to come out of 257. Pretty sure 257 is a prime number. All right, so because we're doing square roots, we're looking for pairs of 2. If it was a cube root, you'd look for pairs of 3 to pull out. So we're looking, well, sets of 3, sorry. We're looking for pairs of 2, so we can pull out 1 5, we can pull out 2 5s. So you have got the square root of 5 squared then you have the square root of 5 squared, and then the square root of 5, and the square root of 257. These are all multiplied by each other. Well, we know that squaring and square rooting cancel each other out. So what you're left with is 5 times 5, square root of 5 times 257. So that's 25 times the square root of 1,285. So x equals 25, the square root of 1,285. All right, so again, sometimes we are going to need to math with simplified square roots. All right, so your assignment is on McGraw-Hill. A lot of people found the assignment fairly straightforward. Just remember, you recognize what A, B, and C is, so you can fill in your equation properly. All right, good luck.